Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify criteria for aromaticity, non-aromaticity, and anti-aromaticity. Aromatic, cyclic, planar, fully conjugated, follows Huckel rule, 4n plus 2 pi electrons. Anti-aromatic, cyclic, planar, fully conjugated, follows 4n pi electrons. Non-aromatic, does not meet all criteria for aromatic or anti-aromatic, not planar, not fully conjugated, or not cyclic. Moving on to the next step. Analyze each compound. A. Naphthalene, bicyclic, planar, fully conjugated, 10 pi electrons, 4n plus 2, n is equal to 2. Aromatic. B. C8H8, 2. This is the cyclotetraene Cot is tub-shaped non-aromatic, but adding 2 electrons gives 10 pi electrons, 4n plus 2, n is equal to 2, planar. Aromatic. C. Cyclobutadiene dianion, square with inner square, drawn as cyclobutadiene, 2C4H4, 2 has 6 pi electrons, 4n plus 2, n is equal to 1, planar, cyclic, fully conjugated. Aromatic. D. Cyclotetraene, cot tub-shaped, not planar, not fully conjugated. Non-aromatic. E. Imidazoline, 4, 5. The hydroimidazole 5-membered ring has 1 C is equal to N double bond but C4, C5 bond is saturated, sp3 carbons, not fully conjugated. Non-aromatic. F. Benzene, 6 pi electrons, 4n plus 2, n is equal to 1, planar, cyclic, fully conjugated. Aromatic. G. Cyclohexene, 6-membered ring with 1 double bond, not fully conjugated. Non-aromatic. H. 1, 3, 5. Triazine with lone pairs, 6-membered ring with 3n and 3c, alternating double bonds, 6 pi electrons, planar. Aromatic. The lone pairs shown are in sp2 orbitals, not contributing to pi system in the way that makes it non-aromatic. The ring pi system has 6 electrons. I. C3H3 plus 1, cyclopropenyl cation 3-membered ring, 2 pi electrons, 4n plus 2, n is equal to 0, planar. Aromatic. J. Cyclopropenyl cation with O, essentially a hydroxycyclopropenyl cation. The 3-membered ring is aromatic, 2 pi electrons. Aromatic. K. 4-membered ring with N, azete or 1-azetine type shown with 2 double bonds in a 4-membered ring containing NF fully conjugated 4-membered ring with 4 pi electrons, 4n n is equal to 1, it is anti-aromatic. This appears to be azete, 1H azete, or similar with 4 pi electrons in a planar ring. Anti-aromatic. L. 1, 2. The hydronaphthalene, 2 fused 6-membered rings, 1 ring is aromatic, benzene, the other has 1 double bond and 2 sp3 carbons. The molecule is not fully aromatic overall, it contains 1 non-aromatic ring. Non-aromatic as a whole molecule. Moving on to the next step. Count W, aromatic, X, non-aromatic, Y, anti-aromatic. Aromatic, W, A, naphthalene, B, C8H8, 2, C, C4H4, 2, cyclobutadiene dianion, F, benzene, H, triazine, I, C3H3, plus, J, hydroxycyclopropenyl cation is equal to 7 compounds. W is equal to 7. Anti-aromatic, Y, C, if cyclobutadiene neutral. Re-examining compound, C, is drawn as a square with inner square suggesting cyclobutadiene itself, neutral, which has 4 pi electrons, anti-aromatic. Then C8H8, 2b, is the dianion of cot is equal to 10 pi electrons, aromatic. Revised analysis. C. Cyclobutadiene, neutral, square 4 pi electrons, anti-aromatic. K. Four-membered ring with N, 4 pi electrons, azete, anti-aromatic. Anti-aromatic, Y, C, cyclobutadiene, K, azete is equal to 2 compounds. Y is equal to 2. Aromatic, W, A, naphthalene, B, C8H8, 2F, benzene, H, trizene, I, C3H3, plus, J, hydroxycyclopropenyl cation is equal to 6 compounds. W is equal to 6. Non-aromatic, kiss smiley, D, cot, E, imidazoline, G, cyclohexene, L, 1, 2, dihydronaphthalene is equal to 4 compounds. X is equal to 4. Check 6 plus 4 plus 2 equals 12. Total compounds is equal to 12. Correct. And for the final step, determine Z compounds that readily undergo dimerization at room temperature. Compounds that dimerize readily are those that are anti-aromatic and highly reactive. Cyclobutadiene dimerizes via disalder at room temperature and other strained reactive species. Cyclobutadiene, C famously dimerizes at room temperature. Yes. C3H3 plus I and J cationic species, not known for dimerization. Azete, K also very reactive and can dimerize. Yes. Cyclohexadiene or similar, 1, 3. Cyclohexadiene can dimerize but compound, G, is cyclohexene, less reactive. For Z is equal to 2 compounds, C, cyclobutadiene and K, azete undergo ready dimerization. Z is equal to 2. Sum W plus X plus Y plus Z is equal to 6 plus 4 plus 2 plus 2 equals 14. Therefore, the correct answer is W plus X plus Y plus Z is equal to 14. The correct answer is shown on screen.